Hey everyone, and welcome back for another deep dive. Today we're going to be tackling something that honestly affects, like, all of us, right? Making sense of data. It's everywhere. And you, awesome listeners, have sent in some really interesting stuff this time, focused on how we use programs as tools to actually understand all those numbers and, well, not get completely overwhelmed.
Yeah, data can be pretty daunting.
For sure. So our main goal here is to break down these resources and really get to the core of how these programs can guide us, like almost show us the path to finding actual knowledge within all that data.
Absolutely. The material you shared comes from a couple of YouTube transcripts, actually.
Yeah,
Code
sure.
Curious videos, to be exact. They feature Sandy Chikrek from Riverside Brookfield High School. And the titles, let me see, yeah, AP, CSP 241, using data with programs, and then AP CSP 242. So the same, just part two.
Nice.
So we'll be diving deep, literally, into how programs go way beyond just storing data. They can actively help us make sense of it all, find those hidden patterns, and ultimately build up our understanding of, well, whatever it is we're looking at.
Okay, love it. So, like, right off the bat, the main takeaway here is that programs are essential for getting any actual insights from data. Just having those numbers isn't enough. We need the tools to actually process them.
Exactly.
And it's funny, Sandy describes this whole process as this back and forth, this really interactive kind of exploration. It's not just a one-time thing, right?
No, not at all. What's really cool here is the idea of a conversation, almost, between the person analyzing the data and the data itself, all facilitated by the program. So it's this cycle of using the program to ask questions of the data, see what answers come back, and then refine your approach based on what you see.
Okay.
And that often involves, some key actions, things like filtering out what's not relevant, cleaning up any mistakes or inconsistencies in the data, maybe even combining different sets of data, and then, of course, grouping or categorizing it all in ways that actually make sense.
It's kind of like, I don't know,
Right.
panning for gold, right?
Fair
You
enough.
got to sift through all the dirt and gravel to find those little nuggets. And those nuggets, as Sandy calls them, are the patterns that become visible when program helps us, translate and transform all that digital data into something we can actually understand. It's like the program unlocks this hidden story within the numbers.
Precisely. And to make this even more concrete, really tangible, the first video uses a super relatable example. AP test scores from 15 students across 3 assessments. So exam 1, exam 2, and then a practice exam 3. Gives us a nice, manageable data set to really see these principles in action.
Okay, I like it. So the first step they show is how a program can take all this raw data and just organize it. In this case, using lists.
Yeah.
Kind of like taking a messy desk full of papers and notes and putting them all into folders, right?
Yeah.
So you can actually see what you've got.
Exactly. And once the data is structured like that, nicely organized, the program can do things like sorting. In the video, they show how sorting students by their score on each exam, from lowest to highest, can already start to reveal some interesting trends. What jumped out at you from that sorting process?
Well, even with just 15 students, you could immediately see there was some consistency. Like one student always seemed to be at the lower end of the scores, no matter which test, and another consistently scored quite high.
Right.
But what was more interesting, I thought, was that middle group. It wasn't always the same students. So, that suggests maybe different strengths and weaknesses depending on the particular exam material.
That's a great observation. The sorting lets us quickly identify those outliers, like the super high and low scores, but also get a feel for the overall spread of the scores. But then they go on to show another cool technique, highlighting. What did you think of that, using visuals like that to understand the data?
Oh, that was really effective. It made the progress really jump out. So they highlighted scores in exam 2 that were better than exam 1. And then they did the same thing, highlighting scores in exam 3 that were better than in exam 2. And it was so clear immediately that most students had improved significantly from exam 2 to 3. Much easier to see than just staring at columns of numbers, right?
Absolutely. And what's really cool is how a simple visual cue, something our brains just process so quickly, can transform a table of data into this clear story of improvement. It really shows the power of that interface between, the program and our own human perception. And this naturally leads us to the idea of summarizing data, which they also touch on.
Right. So like using averages, they calculated the average score for each of the 3 exams, and there's a very clear upward trend, as you'd hope to see. Gives you that big picture view of how the whole class is doing. Then they go on to talk about data transformation, specifically curving the scores. I'm curious, what's the real benefit of being able to manipulate the data like that?
Well, if we zoom out a bit, data transformation shows how flexible and powerful programs can be. Curving scores is just one example, but really data transformation is about changing the format or the values of your data to make it more usable. So that could mean converting units, like from inches to centimeters, or calculating percentages, or even creating new metrics altogether based on the existing information. So for example, if the instructor wants to adjust those scores for any reason, a program allows for that systematic change across the whole data set. And importantly, any summaries, like that average we talked about, are automatically recalculated. Shows the efficiency and accuracy that programs can bring.
Yeah. And it really highlights that interactive aspect. Sandy emphasized how users can filter, sort, combine, transform all these actions, open up new ways of questioning the data and uncovering even deeper insights. It's not just passively looking at numbers, right? It's about actively engaging with them.
Exactly. Each interaction is like an opportunity to ask a new question, leading to another round of processing and the possibility of uncovering a whole new layer of understanding. And this actually leads us really nicely into the second video, which digs deeper into the steps involved in processing information to get to those insights.
Okay, yeah. So now the focus shifts to how we pull actual information out of the data using these programs. And they make a great point that the insights we find aren't meant to just stay as numbers, right? They're often communicated using tables, diagrams, text, and other visual aids, making those findings accessible and understandable.
That's a really crucial point. The goal isn't just to manipulate data for the sake of it. It's about using those manipulations to reveal knowledge, patterns, insights, and then communicating that effectively. And the video also highlights the importance of search tools for quickly finding specific pieces of information within a data set, and data filtering systems for zeroing in on those key patterns within larger sets of data.
Right, right. And they actually give spreadsheets a shout out. They talk about how versatile they are as tools for organizing, filtering, and analyzing data to uncover trends. And I think a lot of us have at least some experience with spreadsheets, so it's a really relatable concept.
Absolutely. Spreadsheets give us a way to do a lot of these fundamental data processing tasks without needing to write complex code. They're very user-friendly, but the video then moves on to outline specific processes for actually extract or modifying information. What stood out to you there?
Well, they talk about transforming each individual piece of data within a set. Like applying that curve to every single test score, for example.
Right.
And then there's filtering, which we saw with identifying those students who scored below average.
Yes.
Combine or comparing different data sets is another important process. And then, of course, visualizing the data using charts and graphs, making it more visual.
Absolutely. And the specific example they use for visualization is box plots of those AP test scores. I'm curious, what did you see in those visual representations that maybe the raw numbers or even the sorted lists didn't convey as clearly?
Yeah, those box plots gave a much clearer picture of how the scores were distributed for each exam. You could immediately see the full range, from the lowest to the highest score, but also where that middle 50% of scores was clustered, and the median score. So for example, it was really clear that the lowest score on exam 3 was higher than the lowest scores in the first two exams. And the whole body of scores had shifted upwards in that final practice exam, showing overall improvement. But you could also see that exam 2 had a wider range of performance, more variability compared to the other two.
That's so interesting. It really shows how powerful visual summaries can be when you're dealing with lots of data. As Sandy points out, if you're presenting findings, a clear visual, like a box plot, is way more effective than a table full of numbers. It's easier to understand and has more impact. It lets you quickly compare those key statistical features of the data, not just the averages.
Yeah, for sure. And then they circle back to search and filtering in more detail, explaining how search algorithms, whether they're built into a spreadsheet program or created from scratch using code, can help us find specific values like the highest or lowest score super efficiently.
And what's fascinating to think about is that even something as seemingly simple as finding the minimum or maximum value relies on programmatic logic behind the scenes. These algorithms systematically compare each data point until they find those extremes, like a detective meticulously examining each piece of evidence to find the most important clues.
Right. And filtering, as we saw with those below average students, allows for really targeted analysis. They also show how combining searching and filtering, like counting how many students scored above a certain threshold on each exam, can clearly demonstrate progress over time. You can quantify it. So for instance, if the number of students scoring above, let's say, 50 increased across all 3 exams, that's a pretty clear sign of improvement for the group as a whole.
Exactly. By setting that specific criterion and then counting how many data points meet it across different categories or time periods, you can objectively measure those trends and changes. And they even touch upon the fundamental programming concepts that underlie all of this, like selection using if statements to decide which data fits a condition, and iteration using loops to perform the same action on multiple data points. For example, a filter might use an if statement to pick out only the scores below a certain value, and a loop to go through and check every single score in the dataset.
Oh, interesting. So even when you're using something user-friendly like a spreadsheet, there's this whole layer of complex logic running in the background,
Right.
making decisions and repeating actions on the data. And for more complex or custom analysis, using programming languages with their ability to handle lists and other data structures gives you even more power and flexibility. Wow.
Absolutely. So, as we wrap up this deep dive, I'm curious, what are some of the key insights or takeaways that really resonated with you about using programs to work with data?
For me, the biggest takeaway is that programs are absolutely essential for turning raw data, which can be messy and overwhelming, into something meaningful and understandable. It's an active process, not passive. It involves trying things out, refining your approach,
Yeah.
and it relies on a whole set of techniques, filtering, sorting, transforming, visualizing, all working together to help us see those patterns and trends that would be invisible if we just looked at the raw numbers.
So true. And it's crucial to remember that understanding these processes isn't just for tech people. As data becomes even more important in our everyday lives, having at least a basic understanding of how programs help us analyze and interpret it is becoming a vital skill for everyone.
Couldn't agree more. So, to all our listeners out there, here's something to think about. Consider a data set in your own life or your area of interest. Maybe it's tracking your finances, monitoring your website traffic, or even following your fitness goals. What questions could you ask of that data? And if you were to use some of the techniques we discussed today, filtering, sorting, visualizing, what surprising insights or new perspectives might you uncover? What stories is that data trying to tell you if you have the right tools to listen?
What a great question to end on. Thanks for this fascinating discussion.
Absolutely. Thanks for joining me today, and we'll see you all next time for another deep dive.